I wish I could grow a mustache like that.
It's the hair.
You can always glue it up.
I think they should. Yes.
I tried.
Ready?
Right, yeah.
All right. So about a year ago, at the Haxe conference, I did a presentation about our first array to Haxe React. And since then, a lot has matured. We have used that in production, kind of using that vanilla, and we've improved on it. We've added a whole lot of macros, experimented on other things, and we're in a situation where now it's pretty stable and pretty good to use. So to give a bit of background, so Massive Interactive has been contributing a lot to the Haxe ecosystem. We've written a lot of libraries. It's been a lot of work to just maintain the libraries beyond the fact you have to write them, you have to maintain them. That's a big engagement when you put something on GitHub. We unfortunately have a number of libraries that we don't maintain actively, and that's a shame. So on the other side, we've attempted to work for all the platforms, all the Haxe platforms. And again, that's a big effort. And what we found out is that we did a good job at making things with JavaScript. So we chose to kind of focus on Haxe JavaScript. And while we focus on JavaScript, we also wanted to use off-the-shelf libraries. So writing everything from scratch is a lot of work. There are excellent libraries made by companies that invest a lot of time and effort in making them very solid and very good. And generally JavaScript has been a good runtime language. So we're happy to focus on that, and that's a bigger, again for us, that's an effort big enough. So then we want to say why Haxe and JavaScript. There's a lot of good things happening with ES6, with TypeScript. There are like the juggernauts, the elephant in the room. But still, people continue making new language, making Elm, making Scala to JavaScript, making Canon to JavaScript. People still are attached to using this language that they like, because they think on the margin there are things that they prefer. Almost any language compiling to JavaScript is adequate, and you kind of have to choose one, and we like this one, we like Haxe. So React and Haxe. React is a good library. It's a popular one. I will show you a bit more about what it is, because a lot of people don't know it. We could make this system work with other similar libraries than React. So we don't want to be closed. We don't want to write something as complex as what React is ourselves. We don't want to do that. There's many thousands of people making these libraries better for free for us. So let's use it. Making them work well for Haxe is already, again, like a significant effort. So part has been done by Massive, started by David Peak, which is also a big contributor to Haxe libraries. Then myself doing a lot of the continuity and the new research and new development for it. But there are a lot of good contributors like Kevin and Tabojad. I'm not sure about his name pronunciation, but both have been creating a lot of React-related libraries, add-ons. Kevin has been working on one of the things that I mentioned, which is React Native, which is very exciting future. So clearly we are in JavaScript world, so if you are going to look into React, that's probably you are already in JavaScript, or you are going to look into that and understand how it works. You can play with things like Create React App, which makes it very easy to scaffold some test JavaScript project, and you can play with it, prove that things work before you like prototype, before you go making your Haxe project. So you can do about anything. In Haxe you can do JavaScript. May not be always elegant, and you will want to hide it if it's not elegant. But, so I wrote a couple of things around how to do it. My very old blog. And a few things. So React. What is React? Probably have all heard about it even if you didn't use it. It's a pretty good thing. It's like XML in your code, like JavaScript in HTML reversed, HTML in your JavaScript. So that's the JavaScript version. So what it does, it is an AEST transformation operation. So you have a div tag, it has a number of attributes, and it has children elements. And that literally transforms to that, to a function call with the properties, so the node, the attributes, and the children. So you can generalize, you can nest that into any complex DOM that you can imagine. It's obviously a lot nicer to write that than to write that, which is why there's this JSX thing. What does this do? It is creating objects. And these objects are not components, they are not DOM elements. We are in a view layer system that is virtual, and in principle, one point of React is that it could be applied to anything. So what is the response of that? What is the result of that is just a small object. It's kind of that is metadata. That is creating metadata, which is the type and the rest of the properties. So which means by default for every node of your HTML-ish, XML-ish DOM, you have a function call and an object. But that is light, this is not a component. You don't create any custom logic, heavy logic with doing that. So what will happen is that you will have the React machinery, the virtual DOM machinery, that will take control of that and do something useful with it. So how would it look like? Oh, there's more. There's binding. Logically, if you look at that, this could be a variable. This could be a variable. So obviously, there's a binding syntax where you can use variables. That's in JavaScript, and that's going to be similar in Haxe. And really, the thing is that what is the whole point of that? Why do we do this kind of syntax, and why it is important and relevant? So it's a virtual DOM. That's a view layer. That's how you just manage the rendering. That's how you manage updates. It is not limited to DOM. There are a lot of a lot of backends for React, and you can write your own. So one of them is for Pixie.js. You have a number of them that some are for Canvas. So there's one by Flipboard team doing a Canvas one. The point is that virtual DOM and view layer is the point that we want to make that simpler and more compact, because if you write everything by code, if you have done ActionScript, or it's like manual ActionScript versus flags, XML declarative versus writing everything by hand. So we use React because that's one of the simple and robust solutions. There are others. And also because we are thinking long term that we are going to be using that as well for native development. So a view layer doesn't need to be specific to a technology. The virtual DOM just works with native, and there's this React Native initiative which is getting a bit mature. And we don't use it yet, but we think it's going to be an interesting long-term solution. So it runs on the JavaScript VM, can run on native. So we have the simplicity of JavaScript development, a virtual DOM, and we can have the native performance. So we're looking for that. So in Haxe, it is not as compact as syntax. We cannot like invent a lot of AST syntax in Haxe, but it's fairly similar. You need to call kind of magic function, and the rest of the syntax is the same. So this is a bit of div. This is with binding. You can use the same binding as in JavaScript. And you can use the Haxe-like string interpolation. The benefit is that you have editor's integration and you can have code completion, usually. But both are working, both are valid. It's a matter of taste. You can use with or without the braces, like for any string interpolation syntax. One of the things is that, as I was showing, this is generating a function call, and this function call has a cost when you have a lot of elements, and we are able with Haxe, and thanks to the type system and type discovery, we are able to generate directly the JSON literals that are normally the result of the function calls. So this is more than currently what JavaScript systems, JavaScript J6 compiler can do. We know that Netflix has done experiments to improve that, and they're doing post-processing to kind of replace the create element calls by these objects. But they have to enforce a lot of limitations that we do not have. And so we kind of have that, we are capable to doing that very efficiently. So that's the result of this year of experimentation and progress. We've improved JS6, we've done these compiler optimizations. So generally, the JS6 parser is nearly complete. It has still a few parts, but it's mostly there. It supports all the features that you don't know that you need, like spread operators, default values, functional stateless components. If you get into React, that would be obvious. We can do better than most of the JavaScript compilers. So that's very good because we are working with low power devices, for instance, or TVs, or set-top boxes. So you have to save as much power as possible. And that's a good, that's all a good follow-up from the previous presentation, because this is all macro magic. And Haxe build types, and all of that. There's a lot of that. It's hopefully completely hidden, and you don't want to add more magic to that. That is where we want to be. So for the most of you who haven't used React, so the basic of virtual DOM is you need to have a starting point where you create one DOM, one virtual DOM. So for HTML, it's React DOM render. You provided a DOM element, which is a root element, and you provided your JS6. This typically happens only once. You initiate, you create the initial DOM, and the DOM has to update itself using the React updating mechanisms. You're not supposed to call that, you are not going to call that every time you want to re-render your application. But you can call that many times. So that is typically why it's been popular to migrate to React in projects, because you can start making some components with React, then some strings with React, and then your entire application has been migrated to React. So that's why it's been a popular migration system. It's, you know, it's a view layer. You can use it in different places and migrate progressively to it. So that's why it is a fairly painless migration potential. Unlike migrating between Angular 1.5 to Angular 2, or between that and Aurelia, or Vue.js or whatnot, this is, well, Vue.js would be another library we could migrate progressively, but React is one of them. So, basic example, you could render a static DOM with React. Render once, becomes some DOM in your page. This will never update. So, what you would have to do is to re-render in a container. So you could render and re-render a component, but that's not really useful. That's not how it's supposed to be done. The principle of the virtual DOM is that components in this DOM will trigger updates. So you need in your initial render to have at least one component. So here we're using the same bracket syntax and including what would be a component. And this component should have a life cycle where it's going to update itself. By updating itself, it is going to cause re-renders locally of your DOM. But you typically only do that once. When that is set up, it will work together. It will work on its own, just using the React machinery to update your DOM when things change. That would be a very minimal component. A minimal component has a render function and has to extend React component. That would be very basic. And this render function has to return JSX, which is React elements, which are virtual DOM definitions. They will have to be transformed into actual DOM or Pixie.js displays or native iOS Android views, depending on the components you're using in your markup syntax. But this is still static, it will not update. So we need to change its state. So the next thing is that the component has a state. You have to set the state with new values, and by setting the state, React will schedule DOM updates. An update means it's going to call again the render function, get the metadata that you have emitted for the render function, and it's going to do a comparison. So, did that change, did that change, did that change? Or we have new elements, or we remove some elements. So it's going to try to efficiently create and update DOM and components. So set state will update this.state object that you can use in your markup, so that this.state goes through and comes from set state. The second mechanism is the props. So for everything that is static, which is external configuration, which is injection in your component, it is the props. So the props are attributes. So title attribute of a my button component. So this button can render and use this.props.title. So props are read-only. They can't be changed. The only time this will change is if the parent re-renders and returns objects with different properties. Changing the properties will mean that React will call the render of the component again with new properties, so it will provide a new DOM for the component. I've shown just React components And here you see we have props and state which are not typed. We want to type them, so React component is an alias to component of dynamic props, dynamic state. And you can obviously say component of specific state type, specific props type. Obviously, when we are in this case, we are creating components that are kind of heavyweight because they create a class instance to just do a dump rendering. So it can be simplified by just a function. And you can just use a function so that the stateless component is just a functional component. It will receive the props in the attributes, returns metadata, return JavaScript JSX elements. And that's all. That will be done. And whenever this component is used in a parent component, whenever it has to be, whenever the parent re-renders, it's going to call the render function. Call this function like a render function with the props. I hope you start to see the way that you create components. This component can change state, will re-render. Here we can have child components. These children component can have attributes. These children components can be classes or functions. And you will define your UI like that. You will design and compose your UI with components. Composition is a keyword here in React. You don't want to create very complex components, and you don't want to extend components by using traditional inheritance mechanisms. So what you do typically in React is to use high order components, for instance. So this is one mechanism. So this component returns another component directly. So it will not exist as is in the DOM. It will not create a DOM element for it. It returns some other elements who may or may not return DOM elements. So that is a way to extend an existing component by creating a high order component that is going to customize or return some modified component. And you want to combine and compose your UI like that. The other mechanism, again, to avoid inheritance is to make component wrappers. So you can make a button to which you provide the children elements. You can make a carousel to which you provide the items. This carousel does not need to know what are the items. This button doesn't need to know what is the content of the button. It will just blindly return some wrapper component and insert inside it the children that's being provided. So two mechanisms, high order components, wrapper components. You should normally not need to inherit in terms of extend classes. This is pretty bad, and it is pretty bad, especially when we go to the next step, which is how we architect React applications. So a slightly more advanced topic, state changes. You probably will need to read about that. I'm not going to spend too much time on that. I do when I do an internal training explaining that. But state changes can cascade rendering. So we render and render the children and the children and the children. That can cause complex recreation of a new DOM and the comparison of all this DOM, and we risk to create useless updates. So there are mechanisms using always the key attributes when creating a list of elements, so it knows what was removed, what was added. So if you create a list of elements, they should all have a key, so that if you remove one element, it will match by key, and knowing that this element has been kept, it's the same, this one is a new one. And then there are code-based mechanisms to control whether rendering is needed or not. So prevent rendering, that's an advanced topic. So generally, like, it's used by, I don't know, millions. I don't know how many projects using that. That's rock solid. And we're starting to be really good and mature on the Haxe side. We have delivered one project which is using React without the macros, like without the JSX, and we have 2 projects ongoing using JSX. So we will hope during these projects to really nail the robustness of the project. So we can be sure that it's going to be seriously solid. Continuing on the boring point is the architecture. It's a view layer, so you can architect as you want. So basically, if you have a JavaScript architecture, you can normally use it almost directly as a view layer. But there are different approaches for architectures. The thing is, it has very few mechanisms to architect an application. It doesn't help you for that. And there are millions of ways to build React applications. So we've done 2 examples. So one with Redux and one with MMVC. I'll go to that point. So Redux, again, in the JavaScript world, this is the big thing. This is a state library for a certain type of architecture, which is called model intent, which means you have a central store. When you want to change it, you don't mutate it. You emit an intent, which is an action. You can think of this action as a system of event bus. These actions go update the store, and that emits a new version of the store. It is based on patterns like immutability, which is very big in functional programming, which means if you hold a reference to the state or a sub part of the state, if you are provided a new state which is the same, nothing changed within it. You know that nothing in the sub parts of this object has changed. They didn't change. Whereas if your object has changed, then you will have to update and check more precisely whether some parts of it have changed. It is incredibly popular. Everybody goes to, like, even Angular apps try to use that as the data store for applications. But it's still a bit young, and you need to build experience using it. So if you start doing that, you will do a lot of refactoring until you wrap your head around how to properly design that. But it's a very, very exciting approach. We have one project using it, and the other architecture is NMVC, so NVC, dependency injection based, like robot legs. So dependency injection, comments, view mediators, singletons, signals, messages. So it's more classic MVC architecture system. So MMVC has been created by Massive in support of robot legs, and we've used this in absolutely huge application, incredibly complex applications. You know, think megabytes of JavaScript, and it's rock solid. If you are into MVC and dependency injection, it's a safe bet. And we made it fit very well with React, so that very easily. So we have another big project using it, and they're quite happy with that because they like the MVC and MVC approach. So these 2 architectures depend on one big concept in React. So if you are going to do that, you will need to be aware of that. It's the context. So far I've just shown you state and props. So if you want to give something to your children, you have to give that in props. So imagine you don't want to give that something to my child, so child and child and child and child and child, in order to provide something down the DOM. That would be very inefficient if you have to provide everything down the components. So the context is kind of a mechanism where you can have where you can provide deep in the view in the virtual DOM. You can provide references and objects. So principle is that you have a provider, which should be a React component, which do not generate any view, usually. And then you have consumer, which are other components that will query the values that are provided. So that's the mechanism. You wrap all your VDOM by the providers, and anywhere deep in your DOM, you will be able to have consumers that can receive the values. That's kind of singleton mechanism within a specific tree. So you can have different trees with provided references. So that's slightly better than service discovery system or singletons. So for Redux, you need to provide the store to all the children and provide a way to dispatch intents. MMVC, you need to wire the mediators to the view. So the principle for MMVC is that when a view is created, you create a mediator that is going to puppet the view. And this mediator will be injected with all the dependencies it needs. React Router, so that most of the interesting libraries in React, which are structural, need this to provide. For instance, if you do application routing, you need to have a way to deep in your application to trigger a navigation. So logically, you need a way to know where you are and trigger navigation. That's just examples. There's a lot of them. Yeah, I don't know if I show you a bit of code. What time is it? How much?
That's okay. Go for it. We've got all evening.
I have quite a lot of things under the rest of the presentation. I could go very far and very long, but let's try to show a bit something. So I'm going to show you, so that is like a to-do application.
Sorry we've been distracting with this. The live broadcasting, it seems to be going okay. There's a couple of complaints about sound. So yes, I don't want to make that just want to like turn your volume up a little bit. If you can, like, project yourself.
All right. So, oh, I need to. Oh, cool, interesting. Yeah. So this is like a to-do app, right? So it is a virtual DOM, and with React, it looks like a classic JavaScript application. I can go and toggle some to-do items. Right? It's not very amazing. As you can see, when I'm touching that, the items get a different color because they have a random color change to visualize that there's been a re-render of the components. If the color do not change, there's no re-render. So you can see I'm changing some state in the application. And in that case, I'm really updating the state of the store, which is based on Redux. And this creates a new list of elements, and this new list of elements leads to potentially re-renders. But I can see it's quite clever in seeing that the items did not change. Only the one we changed the state of the item causes a re-render. So one of the cool things is really debugging. going to check the connected to React. So we have, so what do we have, interestingly? We have a number of things. So we have, well, yeah, I don't know if you can see, we have, I don't know if it's possible to zoom that. Yeah, a bit. Okay. So we do have access to what is our virtual DOM. So although we have normal DOM, and this normal DOM do not have any of the extra elements, it's really straight div nav, div, some more DOM, HR, UL. But you can visualize your actual virtual DOM, and you can see everything that you've been provided. So we have the provider, which is the store provider for Redux. It is wrapping everything, and it is providing this information, providing the context for all the children. Then we have React Router because, well, you can navigate between two pages. So the router is also going to feed the context. So it's wrapping everything. It's going to re-render the content. We have the navigation, so it's some DOM elements with links. So link is a special component from React Router to navigate. It has a number of interesting properties, and it has access to the context. So it has some view on part of the context. Other elements do not have access to that unless they're requested. You have a screen, which is the to-do list view. Then you have some more components, which is this one that has some more DOM elements. We can see all the properties that have been provided. You can see the state. The state of this component is to be a certain message that will be showing up. It has a list of children. We can go and inspect the values of the children. So this one is checked, has an ID and text. So that's a very powerful mechanism of inspecting your application. Makes it very efficient to work with. The other interesting bit is that using Redux, there are also as well tools for Redux, and you can view and this is where you hopefully are going to be mind blown. So the point of Redux is that you model your entire application as one object. So this object has one property, which is to-do list, which is a sub-model inside this general store. It has properties like loading, it's not loading, it has entries, which are the items here. If I check something here, you can see that this had changed to false. Check it, change to true. This state, if I take it, serialize it, reload the page and provide this state serialized, basically you get your application in this state. That's the goal of Redux. And you can mess with it, having local state, for instance, in components. But the point is that you can theoretically entirely reproduce your application. And why is that amazing? Is that because basically you can go back in time. So I'm going to uncheck. That's all the checks that I've done. You can see all the actions that have happened. I can go back. Beginning of it. I'm going to continue going back. Here I had a programmatic insertion of another item, which I'm adding and removing just by going back in time. We had a not loaded state where we were still querying the data, and we can go back to the beginning and replay basically that, which means it is an efficient mechanism because all the data that did not change is the same data, are the same object. So it's not like we duplicate everything in memory. The top reference to the state is combination of previous object that did not change a new object that did change, and you can hold this reference forever. It's just going to give you what was the application, some actions before.
Each time you go back a step, does it mean that it actually calculates the initial state plus all the steps until the previous
No,
one?
no, because it keeps the reference to every single state.
So, oh, really? Okay. So, okay.
And that is not very costly,
Okay.
because the object, as you see, it's going to be, if the entries change, that's going to be a new array, but in this array, all these items will be the same, except at the item where there was a state change. So just the wrapping objects are new objects, but all the items and the entries and maybe the entire, like if you have other objects in your store, they may never change. So how do we use that? So the principle is that to use that, you have to connect. You have to wire your components with this store. So how is that set up? So that taken from the examples I've done. And so what do? We create a store. So you want to have a logic that is going to assemble the store. We can look at that later. Then we create a root DOM element, render once, and here we send a number of startup messages to initiate things. To initiate, for instance, the loading of the to-do. We're not going to look into detail, but if you're interested with that, we create models, and that's this. It's following the normal Redux API, but enhanced for Haxe. So what we're going to do is that normally, if you want to action something, you have to follow a certain API within Redux. So I can show you a bit in a screen. So the principle that you have reducers. Reducers are the ones that are going to update your store. So each reducer is going to update a little bit of your store. The principle is that this reducer is a function that receives the current state, a change request, an action, an intent, and it has to return you either the previous state or a new object, but just for this small part of the store. So that's how you basically put together all your models of your application. So your models could be all spread out as, so if you use an MVC system, you will have a model for your list, a model for that, a model for that, and you will interact directly with each of the models to say, oh, you changed that, you changed that. So the principle is that you assemble them together. The other bit in this system is that you have the middlewares, which are, if you think about this, all these messages that you send, an event bus, this is where you can intercept the messages and process them. So in terms of process, requesting to load the items goes to the middleware, and the middleware says, okay, I'm going to load the items. It's not going to trigger a model change, a store change. Then when he has done its job, he's going to feed the model to go to the reducer and update the reducers. It's not a course on Redux, so I'm not going to do much more of that. But why is it interesting is that if I go here and I'm going to send a message, for instance, I want to have a message where I am like the add new. So this button, add item, you want an action that is going to create a new item, add it to the model, and trigger an update. So when we use, so the principle is that we expose, thanks to some Haxe magic, the dispatch function, which is the traditional dispatch function for Redux. And normally, And we want to use Haxe because they are amazing. So normally you would have to write, and it's valid. You would have to write type, let's say, then we have some payload like, and we give. So instead of writing that, which is untyped, which you have no control, which is not as cool as enums, you can just provide an enum here. How the transformation happens? Abstract. Hope you remember. An abstract can transform the enum into a regular Redux object, and we will unmap it when it goes to the registers and middlewares into the enum. So that is what transits in the system as messages. But on this end, you send an enum, and on the other end, you will receive an enum. And that's all automatic, thanks to abstracts. So if I look at this, at the definition of this function, if it's going to find it, it's going to be long to find it. So it is created by macro. The other interesting bit is how you extract data from the store. So this is a component, this is a connected component, and as a connected component, it will receive a dispatch function, and it will also have a map state function, which should be static, because it's not instance specific. It should be really a functional transformation of, here's the store, this is the entire application state, here are the properties of this component, so you can configure a component and say, provide arbitrary values saying you should behave like that, and it has to transform this state into, in that case, a to-do list state. It has to return a state which is valid, which is transformed, so we get the to-do list model, get the entries, look if it's loading, count the items, say 0 item, or create a string with the text of the items, and we update the state of this object with that. So that the mapping, so that's the concept of mapping the store state into your local state. Normally you want even to make that into a hardware component and immediately provide these values to subcomponents. Here it's not really done well, and we should not include both the mapping and the connection and all the rendering. That's not a great practice, but to keep things simple, that's basically how you wire things together. And we can do interesting things. So we didn't stop here, because that's one absolutely cool thing in JavaScript when using React. And I mean, if you don't do that, like you're not even worth looking at, considering, because if you can't fly to update that, I mean, you're nothing. So I'm going to show we can do some fancy things like the check that, say, oh yeah, cool. Padding. And yeah, let's go back to that, because that's just CSS. That's not very amazing. So let's have something and say hello none. Yep. Because I changed the static, obviously it doesn't look that. Hello. You are. So as you can see, all the colors change when I do that. involves quite a lot of things. And actually, I think I have a bit of hey, where's my to-do list? Interview. Yep. Okay. So, oops. I've removed too many things, I think. So if we want to add something, yes, there's an error in my JSX. Thank you for noticing. Nine. That's right, that's right. You can imagine that you can, the goal is really to build UI directly, quickly, and navigate everything. So both the HTML, the CSS, and the JavaScript. So we've been hard at working on that. I mean, especially me, making all that work. And this all leads to something, is that if I go and change the code, of the add button, if I want to change this text, so if I create that, it's going to say a new task. If I want to say change that, and without updating the code, without losing anything from the application, and again, that could be Pixie.js or whatever, and that would be possible. So without doing that, we can update everything. So the approach of that is, what you need to do for that is to reload your Haxe code. So you know that normally your Haxe.js is one big piece of optimized, compact JavaScript. So as you can see, he's saying reloading the to-do list view. If I go to the if I go here, click something which is a local state, go get the log view. It will say Now we're reloading the about view. So what does that mean? This looks like a class name, right? So what we have is there's a mechanism. I'm going to go back to the presentation probably. There's a mechanism which is where were we? Which is, to do that, we're splitting the application. We get out of the single JavaScript application. So very quickly, the goal is to have a smaller JavaScript when you start your application. We have applications which are multi-megabytes of JavaScript. That is a shitty experience for the users. So what you want to do is to have a small core JavaScript file and get quickly to the user. So how to solve that? Because that's something that the JavaScript community has solved. Well, you have to split everything into something that is going to be faster to download for the user. And also, this is a critical component to hot reload functionality in your application, because you need to just reload the view side, rewire everything, and re-render with the newly loaded view code that you have emitted. So how to do that in Haxe? There's different approaches. This is kind of, the modular JS is kind of the future. I think it's a good long-term direction. Not going to take too much about that, but basically split your Haxe output into individual JavaScript files, and then you become compliant with the JavaScript bundlers and hot reload system that exists otherwise. That is still very experimental. I think it's long-term. Currently it's kind of messy because there are like 4 different folks trying different direction to push the system. So some using a certain module system, some using another module system in JavaScript. I think it's going to be interesting in the long term. And but on the other side, you have to become an expert of JavaScript bundling. So Webpack or BrowserFI or System.js or whatever. Webpack is the more popular these days. It's a very complex system. You have to become an expert of that if you want to use it somehow. So other option which I wrote this year was, which I gave a first hint at the conference last year, and it was a mix of splitting the code kind of manually and using Webpack to hot reload. That was a bit a monster, but the idea was here. So I made it bundler free. It's using its own system to serve and live reload. It's based on the way Webpack hot reload, hot module replacement is coded, is written. So it's based on this code and using the underlying JavaScript libraries that make that possible. So it's exactly the same principle as what you have with Webpack for hot reloading. And so basically, we're butchering the Haxe output automatically this time. Why I think it's an interesting approach is because you could adapt that to other targets. Like the automatic splitting of your output could work with, I don't know, Nico, Hashlink, Sepia, like HXCPP and Sepia. You could use it to emit different applications and make that modular with other Haxe targets. So this is why I think the API, the general approach, is interesting. So what it was is that it actually automatically splits, automatically, if you use the API for, splits the output, splits the source map, it's hot reload compatible, there's a mechanism to efficiently use NPM dependencies, which otherwise can be slow if you use NPM dependencies. You have to run like a post process with another tool that is going to inject your JavaScript dependencies into it, makes the compilation slower, so we can keep that lean and fast to reload. So we're starting to use it massive in projects, so we're going to make that solid and robust. So the API is that you want to use a view, you want to use a class, any class actually. You use a specific API which is bundle load the class reference. It's a promise. When it's done, you can use it. That's completely transparent. You import your class, and you inform the system that you're going to use it asynchronously, and that becomes a split point. And this class and all its dependencies are going to be emitted into their own separate JavaScript file, which could be a CPR script for HTTP, which could be maybe a hash link module, which could be whatever. That's the idea. This API is agnostic, it's target agnostic. And it's very natural. There's no, it's clear what's happening. So again, it's macro magic. This is replaced with something is replaced by the ID of the class, ID of the module that's been emitted to be loaded. React router, forget it for now if you're not using it, but basically there's a slightly different API, but in the application I've shown you, we're defining the route bundle with the class reference, and this marks that we will have an index.js, and the to-do list and the about view are going to be emitted as different bundles automatically. So that's a way, a very, yeah.
Sorry, can you tie progress onto it?
Can you what?
Tie progress onto, so you get like 90%, 50% as it's loading.
Well, that is dependent on the JavaScript APIs. So we use, the way it's implemented behind the scene right now, it's using a script tag. So a script tag does not give you a progress. If it would be, it could be re-implemented using XML HTTP request, which could give you progress. And yeah, you could imagine to evolve this API to provide you a second callback giving you a progress of the download and show something. That could be an evolution of it. But right now is very simply creating a script tag, and when the script tag is loaded, you are called back. So when the script tag, in this case that would be a component, when it's loaded, the callback is executed and you have access to your component. There is some scope wiring magic happening, but it's a natural, simple API. So there are macros. The class reference is flagged as split point, replaced by a fixed API, which is an API meant to download asynchronously scripts. So it's going to load the JavaScript file of this ID, and you can use this API if you want. If you have the JavaScript file, you could just use that to use the principle of creating a script tag, and when the script tag is loaded, having the callback. And the principle is that the Haxe.js output is sent to a temporary file and is going to be butchered. It's not pretty to see. So the processing happens using Node.js. So the compiler runs, saves the files, execute the Node.js tool. Why Node.js? Because I'm not going to, I didn't write the JavaScript parser or whatever. So, and you want the brute force more than Nico to process that. So what happens? We have an output. If you have ever looked at the JavaScript output, you have a class, a header, a class, a class, a class, a class, and you have a map file. So the tool, Haxe split, goes and say, okay, I'm picking that in the main, picking that in the main, this goes here, and this is a dependency of the player, and it recreates the JavaScript files, and it even splits the map files. And it has a bit of, a very tiny bit of wiring magic, which is going to make that possible to join the scopes of several JavaScript files, because normally it's completely isolated when you generate a Haxe.js. So you have to make them join, so you can use the classes of another JavaScript file in the other one. So there's two phases: analysis, using the clone.js to make the action script, the AST of the JavaScript file. Dependency graph is built of all the classes. That is brute force by analyzing the JavaScript AST. And based on that, we know the split points. Emit, like easy. We emit the JavaScript files, and the new source maps split based on that. It's really not that complicated once it's done, but it's it was fun. Yeah, that's about it. So that's the Haxe reload. I'm not going to go more on that. I already shown you. I think I'm stopping here. I've given enough. So yeah, it's you want to Haxe reload code. That's absolutely insanely cool. And that's why people are moving hordes to React Webpack, because they can make their view live reload it. And that is why these JavaScript technologies are really killing the others, because it's so amazing to have this feeling of that you can update your code live. So yeah, that's it. Okay. That was very long.
My questions then? Yeah.
Yes, look at the samples. The samples are fairly complete examples. Yeah.
In the Redux stuff, as you are changing, like because you've got like one main object, yeah.
Mm-hmm.
If you made a change, how do you notify like the objects, the components to update?
So that's the connection mechanism. So when you add the connect interface, what it's going to do is it is going to become a consumer for the Redux store, and it's going to get the store reference, and the store has a change method. So every time it changes, you can subscribe to these changes, and you will know that generally the store somewhere has changed.
Okay, so basically any change you are taking the object anyway and then checking if you are actually...
Yeah, you remap it,
Okay.
and when you map it, you check if you have any changes in the store. So you want to minimize the surface of the connections normally, but even we have quite a lot of connections, it's not a huge deal. Right, I need to give a what to Conrad, who came a long way to show us more magic.
One quick question.
Yeah?
With, I found with just normal React and videos that it would reload the videos when I was...
That's because you need to prevent the state, the re-renders. You need
but
to
even
use...
if it's inside something?
Yes, yeah, you have to use pure component or override the should component update. That's what I was saying. You need to be careful about the updates. It's very easy to trigger re-renders.